This is the solution for additional mathematics, Chapter 10, Permutations and Combinations, Exercise 10.2, Question number 5. Five-digit numbers are to be formed using the digits 2, 3, 4, 5, and 6. Each digit may only be used once in any number. Let's start with Part A. Find how many different five-digit numbers can be formed. Okay, so since there are no restrictions, we have to arrange 5 digits to make a 5-digit number. This can be calculated through 5 factorial. The answer for this part is 120. Now, let's do Part B. How many of these 5-digit numbers are even? To start, make 5 spaces for the 5 digits. We know that the number can begin with 2, 3, 4, 5, or 6.
In order for the number to be even, it must end in 2, 4, or 6. But when we have 2, for example, in the first place, it can only end with 4 or 6 for it to be even, since we can't repeat numbers. We can say that 2 has 2 possibilities that it can end with for it to be even. However, when we have 3 in the first space, it can end with 2, 4, or 6, which gives us 3 possibilities.
Okay, so again for 4, there will be 2 possibilities, which are 2 and 6, and 3 possibilities for 5, and 2 for 6. You can notice a pattern that the numbers beginning with an even number have 2 ending possibilities, and the numbers beginning with odd numbers have 3 ending possibilities.
Now, add up the total possibilities, which will be 12. Okay, so when we decide the first digit and the last digit of the number, we are left with 3 numbers to arrange in 3 spaces, which can be calculated through 3 factorial. Multiply 3 factorial by 12 to get the answer. 72 is the answer for this part.
Moving on to Part C. Find the number of 5-digit numbers that are greater than 40,000. Start again by making 5 spaces for the 5 digits. In order for the number to be greater than 40,000, it must start with 4, 5, or 6, so we can write these in the first space. This means that we have 3 possible digits for the first space.
When we have decided the first space, we are left with 4 digits to arrange in 4 spaces, which is calculated through 4 factorial. We will multiply 4 factorial by the 3 possibilities for the first space.
The answer for this part is 72. Now let's do the last part, Part D. We need to find the number of 5-digit numbers that are even and greater than 40,000. So this part is kind of a combination of both the earlier parts, so it should be simple enough.
Again, we will make 5 spaces. The number must start with 4, 5, or 6 for it to be greater than 40,000. We also know that it must end with an even number, which are 2, 4, and 6. Okay, so when the number starts with 4, it can end with 2 or 6, so 2 possibilities. When the number starts with 5, it can end in 2, 4, or 6, so 3 possibilities. And when the number starts with 6, it can end in 2 or 4, so 2 possibilities. In these types of questions where we decide the first and last space, we only need to add up the possibilities of the last space because we are already accounting for the first space when we decide the last space. Okay, so add up the possibilities of the last space to get 7. We are left with 3 digits to arrange in 3 spaces, which will be 3 factorial. Multiply 3 factorial by 7.
The answer for Part D is 42. That's it for this question. Thank you for watching.